Hello everyone, welcome back. Today we'll be doing temple room on TryHackMe. So let's get started. Let's start off with the RS scan. So RS scan dash A for the target. I have the IP here. You limit 5000 for faster scanning, and then once ports are found, I will be doing the aggressive scan and saving the output in normal format in this file. We press enter and we see a couple of ports open. That is 21 for FTP, 23 as I is telnet, 7 is for echo. I'm not sure what does echo do. Fourth is 22 for SSH, 80 HTTP, and 61337. I suppose it's the Python server, not sure. So let's wait for the scan to complete. Till then, we can browse the port 80. So let's open it. And we see nothing special. Let's Apache to default page. And if we look for any comments, and there is nothing interesting here. We can also see if there is any directories entries mentioned in the robots file, and there isn't any. Okay, so getting back to our nmap scan, we see that 61337 is workzug httpd 2.0.1, and 80 is Apache 2.4.29. This version is not vulnerable. We cannot directly exploit it. Scrolling up, we see FTP, VSFTP 3.0.3. This version is also not vulnerable. And then OpenSSH and 23 for Telnet. So the interesting one is this one. Let's open that in our browser. Looks like this port is not responding. Uh, Not sure why. Let's just check our connection to try help me. Looks like our connection is lost. I don't know why. Let's reconnect and we should get a response back. Um, just a second. Yeah, so wait, 61337. Yeah, so we have our login page here. Looking for comments here. In source code, we don't see anything. Also, if we try looking at robots.txt file, we see a blank page. Looking at the source code, we see it says try harder. Okay, so we have a login page here. Also, we can try GoBuster on port 80 to find any hidden directories, but there aren't any hidden directories there. So I'm not going to waste any time there. So, uh, trying basic SQL injection to get past the login page, we try comma or 1 equals to 1 with the comment. Copy paste the name and password field and login. We see hacking attempt detected. So it looks like the characters like dash or apostrophe are being filtered out because it says detected illegal characters in username. So you can try encoding this via URL encode. So if you even try that thing, that also fails. Okay, so at this point we cannot do SQL injection. We can try for default password, maybe just like admin password. We hit enter and it says invalid password, invalid username or password. Okay, so we don't have anything here. The last option is GoBuster on this URL. So let's do it. Launching GoBuster on this URL and using the common word list with 100 threads. Um, let's see what we find. It may take some time. So we find a couple of directories here. That is account, and it just redirects us back to the login page. So I guess we need to be logged in order to see the account web page. Next one is admin. So we see status 403, and that is because it's unauthorized. We cannot access it until and unless we are admin. So yeah, it's forbidden. Next one is also forbidden application directory. And external one, we see it also redirects us back to login page, so you need to be logged in order to see the external page. Next one is the home. It also redirects us back to the login page, and internal also redirects us back to the login page. So we need to be logged in somehow to the web application. So it looks like every file, every directory here is protected. We cannot access it. So we should somehow get into the application, or we should be able to register our own account so we can get into the application. So there must be a way. Oh my god. So I don't know why these are popping up. This was not expected, to be honest. Let me see if I can still access the page. There is some problem with my VPN connection today. Uh, uh, VPN connection is dying again and again. I don't know why. So let me just download another VPN file. I'll get back to you. Alright, so I have my machine back. I have resetted the box and also launched the Go Booster. So yeah, we see login that was, and we see reverse text. We have already seen it, and we should see another directory here, and that is here. That is temporary. So it says status 403, and we cannot access it either. So there are three directories that are 403 that are forbidden. We cannot access them. But in these directories, there must be some folders or files that if we fuzz the directories, if we brute force the directories, then we should be able to find them and we should be able to access them. So looking for that, we first of all enumerate in every directory. We launch a GoBuster in every directory that are forbidden, like for admin, in application, and in temporary. So uh, if you launch a GoBuster scan in admin directory, you won't find any useful results. Same goes for the application, but if you run it in temporary directory, let's do it here. So temporary, so you should see a useful directory pop up. So that one is also forbidden, but if you launch a go buster scan in that directory also, then we would see another directory pop up that will be useful. So let's just wait for the result to pop up. I guess it's a dev directory, that is dev, maybe it stands for developer. Okay, so after a few seconds, you'll see dev pop up on your screen, that and also it says status 403. So let's just browse it on our browser. So temporary and dev. Oh, my IP is wrong. Uh, let's let's paste it here. Oh God. Okay, so you see we also get forbidden here. With this information, we launch another GoBuster scan on inside this dev directory. Uh, the real pain of this box is right here. You uh, cannot find this directory until and unless you have a lot of patience and trial and error method. So if you try another directory that is named, that is, I guess uh, it's directory list 2.3 medium, if I'm right. Yeah, it's this one. Yeah, so my internet is a bit slow, and this scan can usually take up to 30 minutes for that directory to pop up. So yeah, it takes a lot of patience, you know. So I'm not going to wait 30 minutes here, but if you launch your GoBuster scan in this field and you have a good internet connection, then you would see the result pop up in less than 10 minutes, if I'm right. Yeah. So it will take a lot of time for me, so I'm just going to skip this over, and let's just assume that we found a new ACC named directory with the help of this GoBuster. So I will cancel this out and clear the screen. and we'll see that we have a register page here to create an account. Okay, that's awesome. Let's just create an okay, so I'll say test@test.com. Username would be anything. Let's just say test username. Okay, and password is the email. Email is the password. Let me register, and we see the success account created. All right, so let's log in. We have enter username. Our username is test username. Our password is the email. Let's copy paste. Yeah. Alright, so we have home directory here, we have internal, the ones we found before in our GoBuster scan. There's nothing useful here. Just say we work hard but also play hard. And external at the temple industries.local, so we know the domain name here. And then we have account, it says logged in as, and my username is reflected back on the web page. So whenever I see something like this, I usually, first of all, the thing that comes to my mind is either SSTI, that is server-side template injection, or SQL injection. If my username is reflected with the help of the cookie, then it's usually SQL injection. So we see a cookie named identifier and session. So let's copy this session. I copied this one because you can see here the cookie starts with EYJ, and if you see EYJ, then it's usually base64 encoded JSON format. So let's confirm this using base64 decode. So echo this and base64 dash D for decode. We decode this, we see logged in true, and the username is test username. So yep, I was right, we were right. Uh, our username is reflected back with the help of the cookie. Okay, and also we see base64 invalid input. So it's because of these. You see a dot here and a dot here. So this one is, I guess this one is payload maybe, or this one is payload. And last we have signature, and I'm not pretty sure. We can confirm this by browsing over to jwt.io. Oops, I misspelled it. Yeah, so jwt.io, and we can copy this token and paste it here. And yeah, we have header, uh, logged in true username, test username. Our payload is this, some random integers, and the signature is this. Okay, so yeah, it's divided in three parts. The first one is the header, second is the payload, and third one is the signature, that we do not know what the signature, because it's something secret to sign the cookies. So at this point, you must be thinking like, we should be able to change this cookie, this parameter, and if we base64 encode it, then we should be able to get something like this. And if we don't have signature, then why not just replace the header and leave the payload and the signature as it is. uh, I actually tried the same way. I uh, just base64 encoded this part with some different username. Actually, we can just try it right now. So let's say let's copy this, and it's a echo cookie, and base64 encoded, but let's just say our username to be username. Username. Okay. So base64 encoding it, we get this. And also one thing to note here, that if you base64 encode something using this binary in Kali Linux, then there's some difference in encoding, I guess. So if you go to CyberChef and um, we copy the same string and we encode it as base64. So you see it starts with EYJ and ends with Q equals to, and here you see it's a bit different. So a lot of times I've seen that base64 encode, if I some base64 encode something in Kali Linux, it's usually give out some error. So I just to go on with this CyberChef thing. So let's copy this one, and Let's simply replace the header here. So I paste this, and let's copy this. So I guess we have a cookie here. And if you decode this header till this point, let's say I code this and base64-decode, and it still says base64 invalid input because we have a payload embedded somewhere, maybe, I guess. So yeah, this method will not work. If I copy paste this, then also it will not work. I just skip over it. You can try out by yourself. It will not work. So let's just see if we can do server-side template injection. So first thing, whenever I try SSTI is appending just typing config with curly braces, and let's say password to be as same as username. Let's change the email to test1 register, and says account created. Okay, so let's log in, and we say username to be this, password was also this. We log in, and if you go to account, then you see a lot of results pop up. So this confirms that yeah, this is vulnerable to server-side template injection, and we have our config stuff here. So let's just copy this and just save this into a file. We'll say the file to be config file. Paste it, save it, and let's see the contents. It's a bit hard to read, so what I will do is I will replace the commas with new line. So s slash commas slash n for new line and slash g for global. So I'm replacing it globally, and we yeah, it's a bit readable now. Okay, so here we have environment production, debug is set to false, testing is true, and we have a secret key here, and this is the secret key. So let's just save it uh, in a file named secret key. Also, we have session cookie name and some more results here like trap bad request errors and JSON sort keys and a couple of more results. So at this point, if you don't know what to do with this stuff, then you should always search for some keywords that are new to you, like this one, JSON sort keys, and we search for another term also. Let's take one more. um, let's see, yeah, trap bad request errors. Let's take one more, and that would be our, let's just say, explain template loading. Press enter, and you'll see Flask pops up here, and another one more thing of Flask, and you see this page, result page is filled with Flask stuff. So it looks like one more Flask here. So yeah, it looks like it has something to do with Flask. Therefore, now we know that yeah, it's related to Flask. So we'll say we'll go to Hectrix, and let's append Flask here. So we see Flask Hectrix. Hectrix is a good combination of uh, ways to enumerate and exploit stuff. Therefore, that is why I chose Hectrix and appended Flask in front of it. So if we have an entry in Hectrix about Flask, we should see it, and we do. The first thing it says is that if you are playing a CTF, our Flask application will be related to SSTI, and yeah, it's true here. we exploited SSTI, and then we came to know about Flask application. Then we have Flask unsigned stuff. This is a command line tool that is used to fetch and decode and also craft session cookies of Flask application by guessing the secret keys. So we already have the secret key. So at this point, we are able to create our own session cookies. So we don't have to create a user one by one and see the result of the payload you embed in username. Therefore, you can install the Flask unsigned command line uh, tool with this victory install Flask unsigned. I already have it installed, so I'm not going to do it again. Next thing we have that you can decode a cookie with the help of Flask unsigned. So let's just copy this. Flask unsigned, let's just decode the dash cookie. And our cookie here is, let's just copy the cookie. We paste the cookie here, press enter. And yeah, we see login true, username config, and we don't see anything like basic default invalid input here. Next, we can also sign a cookie with the help of a secret key that we have. So let's do it right now. Let's try it. Flask sign cookie and then cookie. Okay. So let's create a cookie with the following content. I'll embed this in double quotes because we already have a single quote here. Paste it in and let's say let's change this to 7 into 7. So if our cookie is embedded successfully, we should see 49 reflected back on our web page because it's taking the value of username with the help of the stuff that is inside this. Then we need secret key to sign the cookie. So let's see our secret cookie. Let's paste it here inside single quotes and press enter, and we have our cookie here. So yeah, we have a cookie. At this point, you can also decode this cookie that we have generated, so you know that everything is the way you want. We decode this, and yeah, we see that 7 into 7 is here. Let's paste it in here, and we refresh the page using F5, and we see logged in as 49. So yeah, we can at this point sign cookies, and our payload is also reflecting back here. We have SSTI here, and we can craft session cookies. So now let's again search for Hackrix and SSTI, that is server-side template injection. We see a result pop up. We go inside this, and here's a ton of info here using of exploit. So I just search for something like RCE, remote code execution payload. So I search for RCE. I press enter, and so that I can see results one by one. Well, I don't want this. I don't see any useful result. As of now, I'm searching for a payload that contains a command like id, vomi, or ls. So I know that yeah, it's uh, RCE stuff. So here it says method confusion in Go. Well, I don't think we're using Go. Okay. Like, okay, instead of RCE, let's search for SSTI, so set template injection. And yeah, it says typical text expression for SSTI is 7 by 7. We already tried it, but not this dollar. We press enter, and we see Spring View enumeration in Java. We also see expert the SSTI by calling subprocess.popen. And here you see that it's importing OS library, I guess, and executing ls. So yeah, this one seems interesting. I copy this one, and let's create a cookie with display payload like we did before. Let's clear the screen, and Yeah, let's replace this stuff with our payload. And instead of ls, but first of all, I will replace this single quotes with the double quotes, because inside our single quotes is our payload. So let's replace this. Yeah. So also we need to escape them. So we do not see any error pop up on our screen. Okay. Yeah, let's just try executing ls first, so we know that it is working or not. We press enter, we get a cookie. We test whether this is the cookie that we want by decoding it, and it looks like everything is fine. This is inside single quotes. Oh, wait a second. Yeah, it's fine. This is inside single quotes, this is inside double quotes. Yeah, everything seems fine. We change the cookie with our payload, refresh the page, and we see templates and web.py. Looks like our ls command executed successfully, and we have two files in this directory. Awesome. Okay, so once we have the payload here, we have the RC here. We can execute commands. So like we can also see if uh, whether we now our point is to get a reverse shell back from this machine. So uh, before trying any payload, I usually search that if we have Netkit on the machine, because the Netkit usually works fine in every machine. So let's just paste it here, refresh the page, and I see nothing. So it looks like we don't have Netcat on this machine. I I executed which NC to find that we have Netcat. So if you execute which NC in your machine, you'll see it says user bin NC. It will tell you the location of the Netcat binary. But since we do not have that binary here, we will go for another payload. Let's just see reverse shell cheat sheet, and we can also try at Python, but since we have a lot of commas here and stuff, also single inverted commas, so it's a bit risky. It will crash. We don't have netcat, otherwise I would have tried this one. So it looks like I have to go with the bash one. Let's just know our TryHackMe IP. We have 10.11.9.26. Okay, so let's just replace this with this, and I'd say bin bash and dev TCP 10.11.9.26. I'll say port to be 80, because we have a web server. The machine has a web server, Apache web server on port 80, and to avoid the firewall rules, we will use port 80. So, uh, and we press enter here. We get the cookie. Let's just decode it so we know that yeah, it's perfectly fine, and looks like it is fine. Okay, so we open our network listener on port 80 and replace the cookie with the one we generated right now. We refresh the page with F5 and we see nothing pop up, and also we did not get reverse shell back. So it looks like this stuff is not working here. We can also try uh, doing bin bash dash c and pasting it inside. Let's just do it, bin bash dash c. Then this stuff comes inside the double inverted commas. I'm not sure if this will work or not, since we already have two inverted commas here, double inverted commas, so not sure. So I'm not going to try this, because this usually results out with errors. Okay. So at this point, what I will do is, if we cannot get a reverse shell using by pasting this bin bash, then I will just base 64 and code it. Let's see how this works. Uh, let's copy the payload. I'll say echo and base 64 encoded. We have the string here. Okay, and let's so our payload will be uh, let's escape these inverted commas. Yeah, so echo paste base 64 string, and I'll say base 64 decode and then pass it on to bash. So what here will happen is we are pasting our base 64 encoded payload with the help of echo in the terminal, and then we say that base 64 decoded. So when this stuff is base 64 decoded, it will be something like this, the way we want, and then we are passing it into the bash. So this will execute with the help of bash, and this command will execute, and we should get our shell back. So launching reverse cat listener and press enter here. We have our cookie. Let's decode this cookie so we know that yeah, it's fine, and looks like everything is fine. Yeah, so we paste it here, press F5, and we see that it's loading, and it's usually a good sign. And yeah, we have a shell here. Perfectly fine. Let's get TTY shell here. When bash, we will export term equals to xterm just so that we can clear the shell and say clear. Okay, perfect. At this point, we can also see the web.py file. Here you'll see user to be template user and password as this. And we have database to be temple. So it looks like we have a database connection here. We can confirm that by uh, enumerating the ports that are listening. We have 3306, that is default port for MySQL, and it is running locally on this server. So let's log into this MySQL using the user temple user and the password we just found. Paste the password, and we are inside the database. We say show databases. We have one database that is temple. We say use temple database, and also show me the tables. And we have one table that is users. Therefore, I say select all from users. And we see that we have a couple of results here. We have admin user with the username admin and the password is encoded. Same goes for our account that we created. We have email and username and password. So it looks like this password is encoded, and if you try decoding this password of admin, you won't be able to crack it using Rock2 word list or any other word list. Uh, okay, so let's see what it is encoded with. So if you search this up on Google, you say there's nothing found, and we can also go to hashtag mode list. Here, so you'll see a couple of results. So these are the encryptions used to find the what by what method it is encoded with. We can just save this stuff in text file and use John with the word list rocky.txt. So uh, usually this tool automatically detects the hash type. So it looks like it's SHA224. We can confirm that by enumerating the length of this. It's a echo this, and tell me the number of characters it has. We have 57 characters here. Okay, so it was SHA224. Searching this up on hashcat mode list, hashcat mode list. It was SHA224, I guess. Yeah, SHA224. Um, yeah, this one. We have an example hash here. Let's see the length of this. 57 here. Okay, so the both of the hash length is same, so it confirms that yeah, it's SHA224. At this point, you can try decrypting the password of admin, but you won't be able to at this point because this password is secure and it is not found in Rocky word list or any other word list. According to my enumeration, don't know about the others. So this is not the right path. We will skip it. We exit out of the database. And at this point, I usually we don't have a username password. So let's see what files we can write onto and also see what processes are running on this machine as a root. So we say psaux for uh, taking a look at the processes that are running, and we say grep for processes that are running as root. So we see a couple of results here. Scrolling up, we see these are the default ones, not interesting. Here we have a couple of stuff. It's running Python 3, network dispatcher, and cron service. Default ones, Apache server is running as root, and FTP server is running as root. And here we have a long list that is it's of user share Logstash. So Logstash is interesting here because this is not the default service that is being run on any server. Searching for Logstash tells us that it's a free and open server-side data processing pipeline. So we can see what it is used for. And okay, so let's see. So we know that the Logstash is running as root. Also, one more step of enumeration here is finding the files that we can write in onto using find command that is find inside etc directory, and I use a flag dash write table to know the files that we can write onto, and I use to greater than dev null so we do not see any errors on the screen, permission denied errors, and we see one result pop up here that is logstash conf.d and the configuration files, so we can write onto this file. So at this point we know that a process named Logstash is running as root, and also we can write onto a file owned by Logstash. So we get a connection that yeah, this process is running as root, and we can write a configuration file of Logstash. So this seems our way in. Changing directory into conf.d, we see configuration file that we can write into. Let's see what is inside this directory. Sorry, file. It's a sample Logstash configuration file. Okay, we go back and we have more results here. We have pipelines.yml, we see the contents, and we have path.config, etc logstash.conf.d, and every configuration file that is listed inside this conf.d directory. Okay, so at this point we do not know how to exploit it, so again we do log stash and then hactrix, and logstash hactrix, it is mentioned on this page, and it says Prevask with writable pipelines. Oops. Yeah, so it says before trying to elevate your own privileges, you should see which user is running the logstash service. Since this is the user you will be owning, so we know that logstash service is running as root, so we will be as root if we own it. Next thing we should check is whether you have one of the requirements. Okay, so we should have write permissions in a conf file, and we do have in the sample conf file, so it's a check. Then we have further one of the requirements must be met. You should be able to restart the logstash service or at the logstash contains the entry this. So let's see if this contains this entry, the logstash.yml. Let's get this file and grep for config reload automatic. And we see, yeah, it contains config load automatic to true. Okay, so check. Therefore, we have all the requirements met. So we should be able to exploit this using this. If a wildcard is specified, and try to create a file that matches that wildcard. So in our wildcard, it just says that every file that ends with .conf would be able to use it. So we have our file here. Next, it says following content can be written into the file to execute commands. So my command will be executed after 120 seconds, and the output of the command is saved in temporary output.log file. Okay, so we cannot copy paste this stuff here for some reason, I don't know why. So we will go to the Hacktricks GitHub page so that we can copy paste this piece of code. It's in Linux Unix as per the URL, then previous escalation and Logstash. Then Logstash, and it should be here. Yep, here it is. Perfectly fine. I save this as a logstash.conf, paste this here, and instead of OMI, I'll execute our reverse shell payload, and that is inside reverse shell hit sheet. Okay, we have it. Let's copy the bash, replace it. We say port 80 and replace the IP. The TryHackMe IP 26 and interval will be, I guess, 10 seconds. We save this. Open a Python server. Let's open the Python server on port 1234 and open a netcat listener on port 80. Next, we use curl to download the file and override the contents of that file into this configuration file. So curl 10 point, what was the IP? 10.11.9.26, I guess, and 1234. Let's see. Um, yeah, 10.11.9.26, and the file name is logstash.conf -o to override the contents into this file. Press enter, and looks like it's successful, and our payload is right here. So we should get our reverse shell back in 10 seconds, and the output would be seen here. Maybe let's just go to temp. Let's just wait for the reverse shell to pop up. Maybe it takes some time, I guess. Like we do not get our reverse shell back, so let's try changing the payload. Um, it's a nano logstash.conf. We have the payload here. First of all, let's confirm whether our IP was right or not. And our IP is 10.11.9.26. And here we have mentioned 10.11.9.26. It is right. Let's just pass it into bin bash -c. Put this in single inverted commas. And let's save it. Open the Python server on port 1234, transfer the file here using curl 10.11.9.26 port 1234 log stash.conf and output overwrite in this file. Okay, so Let's see. Okay, we get a reversal back right away. So this thing worked. We are root on the machine. We have successfully solved this. I hope you learned something new here. And this room was really, really awesome. I appreciate you that you watched until the end. Let's see you next time.